So Ramesh, what are we going to learn today?
Let's look at data types in our programming language. So,
What's a data type?
so when we declare things, we declare things to be of a certain data type. Declare variables or constants. We we assign a data type to them.
Okay.
So, for instance, I would say something like I define something and I'm going to use a data type. I'm going to explain what I mean by something simple like this. I say you int 8 underscore t and I declare a variable. Let's say there's a count in my variable. I declare like this. What does it mean to declare in this form? Well, we say that we want our declarations to be precise, no ambiguity whatsoever. So there was a standard that the IEEE came up with called the C99 standard. The C99 standard allows us to define things in a very precise way. So this one, for instance, is saying that I have, the U is saying that I have an unsigned number. And this is saying the int is saying that it's an integer, and as
Okay.
opposed to a float or something else, a floating point number, this is saying it's an integer. And the 8 is saying that it is a 8-bit number.
And what's the T saying?
And there's a convention we use in the C99 where any declaration, the T here is basically saying that it's a data type. The type,
nice, nice.
right? So it's very easy to remember and it's very precise, and we are not leaving any chance for any room for doubt when we specify what it is. So let's take a look at some general declarations of variable data types. So we'll notice that we'll make a note quickly that this is the C99 column, right? This is our C99 declaration. And if you notice, whenever we declare something, we will specify what its data type is, and we also look at the range, because this is another way of looking at our data type to decide what is the appropriate data type to
yes.
choose. So we look at the range, and this says this will tell us what is appropriate. So John, do you give negative scores in your class?
Oh no! Always positive scores.
Always
positive.
And so
Negative is so negative.
negative is so negative. So if I were storing scores is the concept I have, that is an entity called score. I would choose within this, I'd say what is the most suitable range for it. So I choose this one because I don't do negative scores. These are too big, and the smallest thing that fits my bill is a 0 to 255, so I'll use scores for it, right?
Nice.
So range, we give you the range for that. Now in the old days, we used to use a very archaic way and very ambiguous way of declaring data types, where we would use things like int. Here's an example of something like that. We would use something like int, and the problem with int is it's completely up to the compiler. On a compiler, on some machines it's 8 bits, on some machines it's 16 bits, some machines 32 bits. So there's a lot of room for ambiguity. So we don't want that in embedded systems, so we abandon this and we use this standard that's well defined.
Nice.
The only addition to this is our character data type. The character data type for us is something that we use all the time, and it's not part of the C99 standard, but it is to use characters that form our strings. So that's an ASCII data type, which we are familiar with.
Got it.
Right? The last note about data types, since we've been working with assembly and C, in assembly, this is a very important thing I want all of us to remember, which is in assembly, there is a size but no signedness.
So when I make a variable in assembly, I tell it how many bits it is, but I can't really tell it whether it's signed or unsigned.
Unsigned. So for example, I say dot long, but I can't say whether it's signed or not. I can say dot short, but I can't say whether it's signed or not. I can say dot byte, but I cannot say what it is. So that's a fundamental difference between assembly and in C. In C, we will actually, this long, we will be more precise about it. We'll say it's an int 32 underscore t when we want to say it is signed, and if we want to say it's unsigned, we say you int
Oh, I get it.
32 underscore t. That's our data types.